Hi everyone, I'm Jia Yuan from Singapore Math Tutors. So today we'll be doing finding lowest common multiple by prime factorization method, okay, according to syllabus. So let's start. So we'll review some terms again before we go to questions. So a common multiple is a number that is a multiple of two or more numbers, okay? So is that certain number that is a multiple of two or more numbers, okay? So now we have two sets of numbers here, okay? They are the multiples of 3 and the multiples of 4. So these are the common multiples, 0 and then 12. Okay, obviously the list goes on. And then our objective here today is to find the lowest common multiple. Okay, so the lowest common multiple of two or more numbers is the smallest number that is a common multiple of a given number. So the small number that is a non-zero number, this is very important. Okay, so what is common between them is 12, which is the lowest one, right? So obviously it's not if we continue the list 18, 21, 24. If we continue here, 20, 24. So obviously it is not 24, right? Because it is not the smallest one. Okay, so it cannot be 24. Right, so let's move on. So now we'll use the method prime factorization. Okay, so you might think that it will work if it's a small number because like you can list it out. So say like 30 and 45. So if we were to list it out, it will be 0, 30, it will be 0, 30, 60, 90, and then the list goes on, right? And then for 45, it will be 0, 45, 90, and then the list goes on. So what's common between them? The lowest common one, as you can see here, is 90, right? So this is possible for like small numbers like 30 and 45. But then like later we'll do more examples whereby we have like bigger numbers. It's really impossible to do it by listing it out because it would take forever. And question like that in O levels are usually like just 1 mark. Okay, so it's not really possible to do it that way. So okay, so we do it by prime factorization. Very quickly, we'll break 30 into its prime factors. Okay, we have done it before in episode 1, whereby we break 12 into its prime number here. Okay, so we'll do the same way again. So 30 is 2 times 15. Okay, and then 2, so 15 is still not a prime number, so 2 times 3 times 5, right? 3 times 5 is 15. Okay, and then 45. 45 is relatively easy as well because 45 is 5 times 9. Then 9, if you remember, it's 3 square. So we have 3 square times 5. So how do we find the lowest common multiple here? What we do is that we will multiply, okay, each factor that occurred the greatest amount of time. So 2 only occurred once in 30 and occurred none in 45. So we can only pick the greatest one, which is 2. Okay. Then we have 3. 3 occurred once in 30 and twice in 45. So we have to pick the one that occurred the greatest amount of time, which is 3 square. Okay. And then as for 5, 5 only occurred once, so we can only pick 5. So if you were to multiply it, it's 2 times 9 times 5, it's 45. So the answer is 90. Okay, so it's the same one as this. Okay, so let's move on. In this example, we have 3 sets of numbers instead. 3 numbers instead of just 2. But we can just list down, break 9 down into its prime factors, which is 3 square, and then 21 into its prime factor, which is 3 times 7. So this example is relatively easy. It is quite unlikely that it will come on O level, but this is just for the sake of example. Okay, so the lowest common multiple here is, so 3 occurred once in 3, 3 occurred twice in 9, and 3 occurred once in 21. So we will choose the one that occurred the most number of times, which is 3 square. Okay, then obviously 7 only occurred once in 21, so we can only multiply by 7. So what we have here is 9 times 7, okay, which is 63. So you can double check it yourself now by listing it all out and then finding the common multiple one, but there's no need, because during exam it is very tedious to do it. So if you were to do it like 3, 6, 9, 12, and then imagine writing it to like 63, and then it's not possible. Okay, so this method is the easiest method, and it is what required by the syllabus, which is you using the method prime factorization to get it. Okay, so again, let's move on to an even more complicated one. So remember these two numbers, 198 and 840. So we did this two example, right, in our previous episode, whereby we find the highest common factor, okay, and of these two numbers. So we have done the prime factorization already. Okay, we have broken both down into their prime factors already. So now what we have to do is very simply just look. So 2 cube and 2 here, right? So 2 occurred 3 times in 840, and 2 only occurred once in 198. So obviously we will choose the one that occurred the greatest amount of time, which is 2 cube. Okay, and then 3 occurred once in 840, and then 3 occurred twice in 198. So we choose the one that occurred the greatest amount of time, which is 3 square here. Okay, so 5 occurred only once, right, in 840, so we can only take 5 here. And then 7 occurred only once, right, so we can only take 7. And then 11 occurred only once in 198, so we can only take that. And then very simply, this is 8 times 9 times 5 times 77. Okay, so if you were to put that into the calculator, you will get 27,720. So this is a very, very big number that it is impossible for you to get it if you were to list everything out, right? Okay, so let's move on to the next part. So in the lastly, I would like to conclude that another way that your teacher might phrase the question for finding lowest common multiple is that they will ask you to find the smallest possible integer, okay, there is a multiple of both 198 and 840. So this is equivalent to finding LCM. Okay, it's the same. So do not fret. Okay, it's the same. So in the next lesson, we will go through on finding squares, square roots by prime factorization. Okay, so see you. Bye.